Hello and welcome to the second part of the Nuage VSP 3.2 application demo. In the first part we saw how we can use a script to fully automate the configuration and the creation of a virtual overlay network for a sample cloud application. And then we can use OpenStack to launch VMs into that network. And as part of the configuration, the script configured a security policy on VSD. So as you can see, this security policy, this is the ingress policy. The egress policy is similar. It can get quite complex especially for real world applications. So what if you're given an application that you are not familiar with or that may not be documented? How would there be a way to can we further automate or optimize this process of defining the security policy? As you can see, there's a new feature in 3.2 which is ACL hit counter, so I can get statistics as I'm using the application. I can get statistics on how often particular rules are getting used. And in addition to a statistic, I also can get syslog events. So I can get an event when a particular rule is being used, and we can use that to build an application that listens for these events and automatically create the policy or the rules that constitute the flows that the application is using. So I have here a sample application. It's again a Docker application that starts a syslog server, and I've configured VSD to send the syslog events to this application. Now, to make it a little bit more interesting, I also have another application here that helps to visualize what's going on underneath. So this application connects to the VSD API and will visualize what happens as I run my security discovery application. I give it the name of the network I want to, or the application I want to discover. On OpenStack, I've built a standard two-tier application, the same application in fact, but I've used OpenStack to create the networks. So there's a front end and a back end, and I've launched a single instance like we did before. Instead of using a public shared zone, this particular instance is having a floating IP on 131. And so what happens if I start the application, it will create an allow all policy, and it will create security groups for every VNIC, every interface of this application. See, so there's a VNIC security group for the front end VNIC and one for the back end VNIC. If I look at VSD on the OpenStack organization, there's my application, front end, back end. And in the policies, this application creates a high priority rule that allows all the traffic. And this rule has the syslog events enabled. So whenever there's traffic on egress or ingress, VSD will send a syslog event. Actually, the VRS will send a syslog event, and the application will receive it. In the visualization application here, I see the creation of these security groups, so the VNIC, one per VNIC. And if I now start to use the application, so I access it on its public floating IP like this, and I do the same scenario as I did before. So user A logs in, registers, I open a hello, that's me. Open a second path, a second tab for B, I register, and then user A calls user B, with audio. And let me close the call quickly. So if I now look at, first of all, at the visualization, see that there is TCP port 80, which I use to access the front end. And then there's TCP port 5060, which is for SIP over WebSocket. That just happens to be how this particular application is constructed. And if I look on OpenStack, the security group, there I see that automatically these ingress rules for port 80 and port 5060 have been created. Now obviously, real applications will have more rules. So just to illustrate, if I go in and I ping a particular IP address in the underlay, what happens is I get rules for ping to this particular IP address, egress and ingress, and you can see it over here as well. And if I do a test and I reboot this particular VM, we see the visualization application is doing reverse DNS lookup. Here we can see that this particular VM is trying to do NTP. Apparently it's configured to reach out to external servers, Juniper Berry and Canonical and Golem. So there's a number of things that this application requires. You may or may not want this, of course, but as you're using the application with this particular script, we can automatically define the security policies and then basically end up at a similar state as what we had when we did it manually, but now fully automated. So that's the second demonstration to show some of the new capabilities in Nuage 3.2. To summarize, we've seen ACL hit counters, we've seen ACL syslog events, we've seen PAT, port-based NAT to the underlay to reach out to the internet or other underlay services. And we've seen the API, the VSD API, which enables us to create these additional applications on top that receive events when objects get created, and then can, based on those events, can program VSD and, for example, visualize or provision security policies to further enhance and simplify the application deployment process. This particular demo will be the subject of a presentation at the OpenStack Summit in Tokyo. We've submitted a presentation proposal to further explain and detail this this application, because it's not specific to Nuage. It's using the standard OpenStack APIs to provision standard OpenStack security groups. So the applicability of this is not limited to Nuage deployments. But of course, if you have Nuage deployed, it makes it easy to develop and deploy these kind of applications on top of your or inside your existing environment. Thank you for watching this demo, and I hope to see you next time.